This video will show you how to use a scatter plot and linear regression to do what's called interpolation and extrapolation, and then we'll talk a little bit at the end about what causation is and how it relates to what we're learning. The first thing you'll have to do before continuing in the video is to enter this data table into your calculator, graph the scatter plot so you see what it looks like, and then use linear regression to find the equation of the line of best fit. There are other videos that show you how to do this, so please stop this video, watch the other ones to learn how to make a scatter plot and do a linear regression, and restart this video when you're finished. Okay, if you did all the work correctly, this should be the equation of your line of fit. Now we'll begin learning about interpolation. Now we're going to use the equation of the line of fit to interpolate. Let's look at the data in the table. The lowest SAT score in the table is 405. And the highest SAT score in the table is 715. Now one might ask, what does this line of fit predict will be the grade point average of someone who has a score that's in between 405 and 715, but it's not listed on the table? So for instance, we might say, what about if someone had an SAT score of 500? What might we predict their GPA would be? And if someone had an SAT score of 420, what would we predict their GPA is? Since these values of SAT are in between SAT scores that are already on the table, we call this interpolation. Right? Now for 500, what we would do is we would plug 500 into the equation of the line of fit. So we'd say y equals 0.0055 times 500 plus 0.0974. And if you work that out and round the answer off, you'll find that it predicts a GPA of 2.8. Next, let's take a look at what would happen if we predicted the GPA for an SAT score of 420. We would take the same equation, y equals 0.0055 times 420 plus 0.0974. And if you work out the math and round off the answer, you'll get a GPA of 2.4. Now I'd like to do one more thing. I'd like to use the equation of the line of fit on a number that we already have in the table. So let's use the number 520 for SAT score. And let's see what our equation of the line of fit predicts. So if you put 520 into the equation, you will get y equals 0.0055 times 520 plus 0.0974. And if you work that out on the calculator and round off your answer, you'll get a GPA of 3.0. Now let's look in the table for 520. The model predicts 3.0, but the actual was 3.2. And that's okay. The equation of the line of fit does not go through all of the points. If you remember from the way the graph looked on the calculator, you'll see that the line, the graph, does not go through all of the points. And what that means is that when you use the equation of the line of fit to predict values that are already in the table, if they're not on the line in the graph, they won't come out exactly right. But again, that's okay. The important thing is that we found the line of fit, and we can use that equation to interpolate. And that means to find values that are within the values in the table but are not specifically listed. Now the next question that we might ask is, what does our equation predict would be the GPA for SAT scores that are either lower than or higher than scores in the table? For instance, what if someone's score on the SATs was 200? Or what if their score was 800? What if their score was 750? What would their GPAs likely be? What does the model predict? Now, since we are finding values that are outside of those listed on the table, we have a different name for that. We call that extrapolation. Extra means it's additional. It's kind of outside of the table. So if we're predicting, once again, if we're predicting values that are outside of the table, that's called extrapolation. So let's use the equation to find out what someone with an SAT score of 200 would likely have as a GPA, and we'll do the same for 750 and 800. The equations we would use as follows. So that for 200, we would compute y equals 0.0055 times 200 plus 0.0974, and we would find that that equals 1.2. So we would assume that if someone had an SAT score of 200, that their GPA would likely be around 1.2. If they had an SAT score of 750, we would use that. And we would find that their GPA would come out to 4.2. And if they had an SAT score of 800, we'd find their estimated GPA would be 4.5. And a number of schools do allow GPAs greater than 4 if the student is taking honors courses. The final concept in this lesson is that of causation. We say that there's causation when a change in one quantity causes another quantity to change. Let's imagine that you studied gas used versus distance you drove, and you make a graph of that. You would see a positive correlation. And we know that if you drive farther, you'll use more gas. So we say that driving farther causes you to use more gas. If you were baking cookies, the number of cookies you make versus the amount of flour that you used, assuming the cookies are all the same size. If you use more flour, you'll make more cookies, so you would expect a positive correlation. Does having more and using more flour cause you to make more cookies? Yes, it does. So we say that there is causation between the amount of flour that you used and the number of cookies that you make. Now let's take a look at the grade point average versus SAT score. We saw that there was a positive correlation between SAT score and grade point average. But does getting a higher SAT score cause you to have a higher grade point average? And no, it does not. There are a lot of things that cause high grade point average. They are things like natural ability, how much you study, how much homework you do, how good your teacher is. All of those might affect your grade point average. But just getting a higher SAT score does not have any effect, does not cause you to have a higher grade point average. So there, even though those two variables have a positive correlation, there is not a causal relationship. There is no causation.